In this video, we'll explore graphs of equations with two variables. So what we're looking at is the graph is all the points in the coordinate plane that satisfy that given equation. So say I want to test out the equation y equals 2x plus 3 and know, do any of these 3 points fall in that equation? Well, I'm going to actually graph the line to the side here, and we're going to test it along the way visually as well. So if I plug in 1 for x and 5 for y, I could then simplify, and I get 2 plus 3 equals 5. 5 equals 5. My left and my right sides equal, so yes. And if I plotted 1, 5, I would see that it literally falls on that equation. Now if I do that for point B, negative 1, 4, I end up with 4 equals negative 2 plus 3. Well, that gives me 4 equals 1. That is not on the graph. If I plotted it, I would see it is off the graph over here. Now if I do negative 3, I end up with negative 3 equals negative 6 plus 3. That's negative 3 being negative 3. And if I plotted that point, I would see it falls down here, which is definitely on the graph. Now we talk about intercepts of a graph. We're talking about the places where a graph of the equation hits the x and y axis. When I hit the x-axis, that's called the x-intercept, and that has an ordered pair of the x value, comma, the 0 for my y value. When I talk about the y-intercept, it's where I'm hitting the y-axis. That means my x value is 0, and then I have my y value where it hit. So say I have this equation and I want to look at the intercepts of the graph. I'd be looking at all the places the x values hit for my x-intercepts and where it hits for the y value for my y-intercept. So if I look at my x-intercepts, it hits here at negative 1, so that's negative 1, 0. It's at 1, which is 1, 0, 2, which is 2, 0, and 3, which is 3, 0. Now for my y-intercepts, I'm looking at where does it hit the y-axis, and it hits down here at negative 6, which gives me 0, negative 6. And if I look, all my x-intercepts have a 0 for y, and my y-intercept has a 0 for x. And that's important because if I'm not going to be able to graph my equation, I need to actually be able to plug those values in and then solve for my missing x, or for which x's work. So for my x-intercept, I'm going to plug a 0 in for y and see are there any x values for which there's an intersection. And then for my y-intercept, I'm going to plug a 0 in for x and see is there any y-intercepts. So let's say we got the equation y equals x squared minus 4. If I want to find my x-intercepts, or where are these places that's hitting the x-axis, I'd want to plug in a 0 for y. So now I'll just solve this. I can either add 4 to both sides, or I can factor, recognizing that's the difference of perfect squares. Either method's fine. In this case, I'm going to factor. Now I'll set each factor equal to 0. So I know that x is 2 and x is negative 2. That means I'm hitting at negative 2, 0 and 2, 0. And I can see that on the graph as well as what I did algebraically. When I do my y-intercept, I plug a 0 in for the x value and solve for y. So I'll plug in 0. 0 minus 4 is negative 4. So that's 0, comma, negative 4. And if I look at my graph, where it hits the y-axis, it's right here at negative 4. So 0, negative 4. Now last thing we'll talk about is symmetry. When we have symmetry with respect to the x-axis, for every x value we have, it also has the point y and negative y for its ordered pairs on the graph. And if you look here, if I draw a symmetric or a line along the x-axis, I can see above and below I could fold along that line and the graph would fall upon itself. With respect to the y-axis, I'm going to have, for each corresponding y, it's going to have the x and negative x on the graph. So if I fold along the y-axis and I then fold this side over, I would see that the sides would match for the graph. Now with respect to the origin, for every xy ordered pair I have, the negative x, negative y has to be on there as well. And this one's kind of different, but if I say that I fold along the x-axis and then I fold along the y-axis, the graph should show up both below and above. So it's kind of like you have to do a double fold to see that other component. So if I want to create points of symmetry with respect to the x-axis, I change the y value. If I want to do it with respect to the y-axis, I change the x value. If I want to do it with respect to the origin, I change both values. So say I have this ordered pair as point 2, -2. If I'm doing it with respect to the x-axis, then I know I'm going to change my y value. So that becomes 4, 2. And if I think about it, here's my line. If I fold across, it would fold up to +2. With respect to the y-axis, I have my ordered pair. I change my x value because I'm folding along the y-axis in this case. So it folds over to -4, -2. And last one is the origin. Well, the origin, I have to change both values. So my +4 becomes negative and my -2 becomes positive, putting me up here at -4, 2. And if I think about it, I fold my point here across the y-axis, and then I fold it across the x-axis, and I get to that ordered pair. Now if I want to test symmetry in a general equation, what I can do is for my x-axis symmetry, I plug in a -y and try to rewrite the equation and see if I can get it back to the same equation. If I can, that is symmetric. If I do it for my y-axis symmetry, I plug in a -x and I do the same thing. I'm going to rewrite it and try to get back to the same equation. And if I need to check it for the origin, I plug in both -x and -y and see if I can rewrite the equation to get back to where I started. So let's say I'm going to look back at y equals x squared minus 4. Now, if I just look at the graph before even testing it, I would assume that I would have y-axis symmetry because I could draw a line here and it would fold on itself. And I would not have x-axis because if I fold it down, it wouldn't match up. And the origin symmetry is not there either. So let's check it algebraically. I'm going to plug in -y here. So if I want to rewrite this equation, I would have to divide everything by -1. That becomes negative the quantity x squared plus 4. Well, that is not the same as this. So there's no x-axis symmetry, which we already said. If I do, and again, there's that line. If I fold it, it doesn't work. If I look at the y-axis symmetry, I'm going to plug in a -x here. Well, -x squared is the same thing as x squared. I think -2 squared is +4. +2 squared is +4. Okay, so that is the same equation, which means I do have y-axis symmetry. And if I drew in the line, again, I could fold it across here and see that's true. Now when I do the origin, I'm plugging in both negatives. Well, this we know makes a +x squared, but then I have to divide by this -y, so I'm going to divide everything by -1, and I get that negative quantity x squared plus 4, and that's not the same. So the only thing I have in this problem would be y-axis symmetry.